Welcome to Lesson 3 of Module 5 on Architectures, Features, and Details of Data Integration Tools. I'm going to start with business questions that I want you to think about throughout this lesson. What business model does Talon use for its data integration products? What distinction does Talon have in the open source community? Lesson 3 extends a conceptual background in Lesson 1 and common product features in Lesson 2. Lesson 3 depicts major features of Talon Open Studio, a prominent open source data integration product. You will learn about the integrated development environment, commonly used component types, and a simple job design example. You have 3 learning objectives in this lesson. You should be able to list major data integration features of Talon. You should gain some familiarity with job design and execution in Talon. As an extended goal, you're encouraged to explore more details about Talon Open Studio, possibly by installing and using the Community Edition of the software. Talon is a commercial firm providing a base open source product along with subscription services. The Community Edition uses a standard open source license. Talon provides subscription services for enterprise editions with extended product features and technical support. Talon offers product extensions for big data with parallel and real-time processing options, data quality with a library of data quality tests, and master data management with data profiling. The Talon Open Studio platform provides common features for job design, metadata management, deployment, execution, and monitoring. Talon Open Studio for data integration supports graphical job design, a palette of data transformation components, a metadata repository, job execution, and database connectivity. The job design component provides graphical specification to define and connect transformation components. The job execution component makes connections to data sources, that is databases, files, and XML data, executes data transformations, and graphically displays execution results. The repository component allows retrievals of job designs, source schemas, transformation components, and job executions. Talon provides a convenient IDE for job design and execution. The repository pane contains components of a job design, as well as metadata about data source schemas, code, SQL templates, and documentation. The design pane contains the outline of job components and a code viewer for components with custom code. The component palette contains a list of folders containing components. An analyst can drag a component from an open folder into the job design canvas. After placing components into canvas, an analyst connects them with data flows. The job pane contains job properties and execution details. The canvas shows a job design or execution. In this snapshot, the canvas contains a job design for an interval match with 4 components and 3 data flows. When a job is executed, the IDE annotates each part of a job design in the canvas with execution details such as run times and number of objects read or written. This table shows icons for components of selected categories of Talon components. Each icon contains a short text description to clarify the meaning of the component. Each component has an associated property window for specifying its property values after it is placed on the canvas. For more concrete details about Talon job designs, this snapshot depicts a job to load an Excel file into a fact table. A job design involves a number of components connected by data flows. This job design transforms input records from an Excel file, that is SS Excel source, to load into the Oracle table, SS Sales, the fact table of the store sales data warehouse. The Excel file input is processed by the T-Schema compliance check component, a data quality component. Null value and data type checks are performed in the T-Schema compliance check component. The output of the T-Schema compliance check component is further processed by the T-Map component. The T-Map component joins on 4 Oracle tables, SS Customer, SS Store, SS TimeDim, and SS Item, to ensure valid foreign keys. The T-Map component uses 4 T-Oracle input components to perform the joins. The output of the T-Map component is loaded to this SS Sales table, a T-Oracle output component. A commercial job flow would also have outputs for rejected records. The Excel job in the slide only has outputs for accepted records. The T-schema compliance check and T-map components would both be connected to additional output for rejected records. Component details are specified using property windows and graphical displays. For example, the T-map component uses a graphical display for join specification. In this snapshot, the fields in the Excel data source are mapped to columns in the SS TimeDim table. The columns in the top part, that is row 1, are from the input file. The columns in the bottom part, that is row 2 of the window, are the SS TimeDim table. A drag and drop method is used to match the columns in a data source and table. This snapshot shows the executed Excel job. The screen snapshot was taken from the Job Design pane after executing the job. You can see that the Excel input file contains 12 rows. The T-schema compliance check component rejects 2 rows for null value or data type violations, passing 10 rows to the T-map component. The T-map component rejects 2 rows for foreign key violations, passing 8 rows to the T-Oracle output component. The job execution documentation shows the number of rows processed along with processing times. Lesson 3 extended the conceptual background about data integration tools from Lessons 1 and 2. Lesson 3 introduced the Talend Open Studio for data integration, a prominent open source tool. You learned about features for graphical specification of transformations, components, and job management, including an example showing job design and execution. You are encouraged to install and use Talend to learn more product details and gain practice with job designs. In answer to the opening question, Talend uses the Open Core model to obtain business value from open source development. The Open Core model involves a feature-limited core product under a standard open source license. Revenue is generated by purchased licenses for commercial versions containing proprietary extensions, along with subscriptions for support services. Talend has the distinction as the first commercial vendor to use the Open Core model in 2005. After Talend's lead, the Open Core model has become widespread, although somewhat controversial in the open source community.